continuation of the previous video on information coding for the purposes of error detection and correction. In this video, I just look at different ways of coding or compactly coding a possible way of compactly coding a permutation. One of which there are several things to observe here. One is the simplest way, the most compact way I would say is in trying to code the cycles. If you have n elements there, a permutation of n elements, and you have a cycle of length say c, okay, and then that means you have to select n element. What you should remember is that if you have a cycle such as say 2, 3, 8, 7 or something like this, that means element 2 goes to 3, 3 goes to 8, 8 goes to 7, 7 goes to 2. Now all cycles of this cycle are the same cycle. So if you take say a cycle of length c, you select c elements out of n. Okay, so having selected c elements out of n, now you can permute them in, that is nothing but nc c. Okay, so c elements out of n is nothing but nc c. These can be arranged in so many different ways, factorial c ways. But out of these factorial c ways, every c cycle of these, there are c cycles of length c which are all identical cycles. So you have to divide by c. So this will give you NPR by C. Now if you take a slightly larger permutation, now we found out that there will be many permutations, many cycles as a composition. Every permutation can be expressed as a product of cycles or a composition of cycles. So if you take a given specific length, for each length you will have a certain number of cycles. It might be 1 or 2 or more, or there might be just be one cycle in it, which means all of them are in different distance. So for each of them you have to code the cycle information. One way is, of course, if you just code one element in a cycle, the first element, and you can code the combinatorial value of that cycle. That will be fairly compact because the number of cycles of a given length will be small compared to the total number of cycles. The total number of cycles will be nothing but NP C by C. Okay, so out of this cycles of length C, right, the number of cycles of this is the total number of cycles, but the number of cycles that are actually part of that permutation will be very small compared to this value. So that combination, if you just code which are the cycles of length c, so a permutation is probably best coded compactly as this thing. Or you could also assume that if you have certain if element occurs in one cycle, it cannot occur in any other cycle. Or you could also try to combine all the elements of a particular length for a cycle and then separate it. Right? If I occurrences of a cycle of certain length occurs, you could take certain length c occurs, I into c elements must be selected from n. Right? And only subset of that alone will be chosen. So that compactly coding the permutation, the cycles alone, right, that should be significantly lot smaller in this manner, will be a lot smaller than the length of the message itself. Now this still will be slightly larger. This form of error detection correction ideally will be suited if you perform it at the file level, meaning you have a big file, a slightly large compressed file. You have a big file there, you compress it to this. Now you perform the permutation on the file, and then you do the recursive coding of, that is the legend or this part of it. First you permute the contents of this, code the entire file, contents of the file as a permutation. Then that permutation, for that you perform the coding of this. Then if need be, to a certain depth, perform code this itself as a permutation and code this here and transmit them, all of them. You will have to do that. That is the best way to do it so that you get it totally error free. You should be able to recover. But also, if you are to consider another simple idea which might be useful if you are transmitting information across a particular link, is to note that if you have MC, if you have a binary number of length L dash, L double dash, L dash, binary string, then if you increase the value of L dash by 1, you can code the entire one in half as many values. L dash plus 1 C L dash plus 1 by 2 greater than or equal to 2 power L dash. Okay, that means you have L dash plus 1 by 2 bits left over. Now, but you have to code another, if you want to say repeat the same value, you have to code again L dash values, right? But you have only L dash plus 1 by 2 positions left over. So what you do is, you have to combine each of these L dash into 2 bits each, so you will have 4 values. So the L dash plus 1 by 2 positions, if you take the base to be 5, out of 5, one specific value you can choose for coding the L dash plus 1 C L dash plus 1 by 2. That particular value, you take up L dash plus 1 by 2 bits to code the 2 power L dash. Now the other, all of these will be in base 5, sorry, but only for the first one it will be one value, which is for the 2 power L dash. For the other remaining positions, you will use the other 4 values by combining them into, taking L dash and grouping it into bits and putting them there in whichever order which you see. Now you have a possibility of checking it. So you first, you can check it. Always you should have L dash plus 1 by 2 bits of one particular value. If you have more or less, it means that the other sum of positions are somewhere error has occurred. So you could try correcting it by seeing which are them where the actual error has occurred. So this way, so in other words, L dash bits is coded as 5 power L dash plus 1 bits. This can be somewhat simply implement. It's not totally very effective, but it will still be reasonably effective to correct a lot of errors. You will know exactly where. Since exactly L dash plus 1 by 2 place position should have only one value, and the remaining position should have 0, 1, 2, 3 or whatever instead of 5. So it will be, you are coding L dash in 5 power L dash plus 1, and you should be able to correct most errors this way simply. You could try generalizing this also, but it may not be all that easy or simple. But so this can be, you can look at other ways also, and you can try to find other ways of compactly and very really fast coding a permutation. So these are the two ways. Some of the other ideas you can have, for instance, you can try to code the distance of it. right? So if you have a permutation like 0, 1, 2, 3, 4, 5, that will also have the same property as that for cycles. Some of the positive positive differences and negative differences will come up to 0. If it goes to 2, 3, 0, 1, 5, 4, distance between this and this will be 0, 1 and 2. This and this, the distance is again 2. 3 is distance is minus 2. 4 is distance is plus 1. 5 is distance is minus 1. Okay. 3 is distance is minus 2. 4 is distance is plus 1. 1 is distance is 2. 0 is distance is 2. Right. So there you have three is also gone by distance minus 2. So you have minus 2, minus 2, minus 1 and 2, 2, 1. So it will add up to 0. So you can either quote the positive distance for the permutation as one of the values. Okay. So this way, or you could try to find, or you can generate permutations itself by cycles itself. Right? You can try to, there are different ways of generating you can sort an element by permuting it by cycling. And you can code just the length of the cycle that you have to perform in order to get the order. So these are all some of the ideas you can explore for trying to compactly code a permutation.